Okay, guys.
All right, welcome back to CFAIL. Just a quick logistical announcement. We still do not have a winner for the puzzle competition, but it seems like some people are close. So what we're going to do is after this invited talk, we're going to give people 15 more minutes to try to finish up. And we're also going to give a hint on the learning with errors puzzle, because that seems to be the hardest one, which is actually my fault and not Eli's. So when we come back after this invited talk, we'll have a little bit of time for that. We'll have a hint, and then we'll finish up with showing some of the answers to the puzzle competition and premiering our music video for this year. But next up, we have an excellent invited talk. The Good, the Bad, and the Ugly, Lessons from an MPC for Social Good Deployment.
Great. Thanks so much. Thanks also for inviting me to give this talk. I gave a version of this talk earlier this year at RWC, and I've expanded it to be even more rich and have even more failures in it to fit with our venue. So what I'm going to do today is tell you about a deployment of MPC for social good that I've been working on for the last 2.5 years or so. And I feel really excited about this work. I'm actually going to tell you the story of it twice, and hopefully it'll become clear why I'm doing that. If you were at RWC, I apologize for reusing some of the same jokes. There's going to be other jokes in there too. So with that, this deployment of MPC was a collaborative deployment with an organization called Museums Moving Forward, or MMF. Museums Moving Forward is an independent organization of art museum professionals. They're devoted to envisioning and creating a more just art museum sector. I guess museums and all, but art museums are really their core area by 2030. So they have the next 5-6 years or so to really put in effort to try and make their field better. What happened is the director of this organization reached out to me and said, hey, we've been doing a lot of really interesting work to try and benchmark what's going on inside of our field, primarily using qualitative metrics. So doing a lot of interviews, a lot of story writing and stuff like that. But we're interested in expanding our purview to include more quantitative measures. And we heard about this thing called MPC. We were really concerned that if we deploy a survey out to everybody who works in the art museum world, they're not going to tell us anything. We want to ask very kind of sensitive questions. Have you been harassed in the workplace? Have you then chosen to report that harassment to your employer? Stuff like that. And they were concerned that if there was not some kind of active privacy protection around this data, that folks would be simply unwilling to fill out those questions. So this seemed like an optimal thing that we could be able to use MPC for. In addition to doing this kind of what was called the staff survey, which went out to about 10,000 art museum workers across the United States, there's also 2 other surveys that they ran, one where they collected data from the directors of museums, and one where they collected directly from the HR departments of museums. There are about 50 participating museums around the country. I'm not going to talk so much about the director and HR surveys. I'll mention them briefly, but they kind of follow a very similar script. One really interesting thing about MMF's use case was that they actually wanted different outputs for different parties. And we eventually decided to name this what we called organizational reports. So the idea is, in order to incentivize museums to participate in this effort, what they were going to do is they were going to release kind of aggregate level statistics about that museum directly to the employees and the director of that museum. But us, and as well as MMF, would not see those kind of organizational level details. We would just see kind of field-wide data. And this was a way for organizations to benchmark their performance against the rest of the field. So we decided to set out and build an MPC platform to actually support them in doing this survey work. We started with a code base that has been used for the last 10 years or so in an ongoing effort between Boston University and an organization called the Boston Women's Workforce Council. This is an organization that every 2 years, they try to benchmark the wage gap in the city of Boston, both along gender and racial lines. In order to, with the kind of guiding principle being, we can't start to fix the problem unless we understand what the problem is. And so there is a beautiful code base that was written to do this. It's been used since about 2015, 2016. There's two things that are important to know about this code base going forward. The first is that it's in the client server model. So what does that mean? It means that lots of people are actually going to input data into the MPC. There's actually very few computational parties participating in the running of the MPC itself. So in this case, there's just two computational parties, but hundreds or thousands of people could fill out the surveys. The second thing that's important to know is that one of the computational parties in the setting is not technically savvy from an organizational standpoint. So I can write code, I can deploy code, that works just fine. But our partner organization, so in this original case, the Boston Workforce Council, for us, Museums Moving Forward, they're artists. They're not able to pull down a Git repo, build it, and deploy it to a server. That's not something that they're realistically going to be able to do. So instead, the entire system is designed very carefully, such that one side of the MPC is run inside of a browser, and then the other side is run on a server by us, and it's all JavaScript, top to bottom. And this is kind of a usability constraint that we have. Good. So the actual system that we built, we integrated a front end. This is just a JavaScript library called survey.js. It looks exactly like every other survey that you probably ever interacted with before. There's multiple choice questions and numbers to fill in and stuff like that. And people would go in and then fill it out. And at the very last step, they kind of hit submit, and their data would get secret shared. So one secret, there's an additive secret sharing scheme. One of the shares would eventually end up in control of Boston University, and the other one would eventually end up in control of Museums Moving Forward. In order to kind of facilitate this, there's only one backend database. So one of the shares, the one for BU, was just stored in clear text in our database. The other one was encrypted under the public key of MMF, and then that public key encryption was stored in our database for later use. We've kind of facilitated the generation of a public key for them using the web interface as well. In order to facilitate those organizational reports that I mentioned before, there needs to be some way to get information back from MMF to individual respondents. And there had to be some kind of secure channel there, but we need to kind of bootstrap that. So in order to do that, we used kind of the thing that people would most likely be able to use, which is they made a password. So they'd input a password right there at the end of the survey, they'd hit submit, and then we just run a KDF over that password along with some contextual information to derive a secret key. And that secret key was then encrypted under the public key of MMF, and eventually MMF were able to use this to encrypt information directly back to the respondents. Great. The MPC itself is relatively straightforward. Not anything really crazy going on here. So what would happen is MMF would log into the system. They would then download all of those public key encryptions that were destined for them. So these are public keys of the shares for all people's information, as well as an encryption of the now shared symmetric key between the client and Museums Moving Forward. They decrypt that all inside of their browser, and then we are ready to do MPC. Nothing particularly interesting to see here. The MPC itself just uses correlated randomness to evaluate nonlinear gates. Otherwise, it looks like a standard 2PC. The tricky part is we actually didn't have a library that could generate us beaver correlations in a way that we wanted. And we didn't have enough time to implement it because the primary engineering effort was my time. And unfortunately, that was a little bit rate limited. And so we went for the non-optimal, but basically a works solution, which was that we integrated a third party into the system that would act as a dedicated correlated randomness generator. And this was hosted at Brown University by our collaborator, Key Mountain. So basically, as the MPC was going on, at some point, it would hit a point where it needed to evaluate a nonlinear gate. It would make an API call. Brown would generate this correlated randomness, send back those shares, and the computation would continue. So if you kind of put all of this together, we ended up with a honest majority, semi-honest 3PC. Great. The outcomes from this were really, really important and interesting to people in the field. I'm not going to go too in depth with them here because we're here to talk about the crypto. But some kind of high-level findings that I found particularly interesting is that art museum workers are more dissatisfied than the average US workers overall, and that many of them are considering leaving their jobs or the field altogether. More than a quarter of art museum workers have experienced some kind of discrimination at their current workplace, but only half of those who have experienced that have actually reported that because they thought the organization wasn't going to do anything about the discrimination. So this was giving kind of hard data to some of the localized experiences that people were voicing and some of the qualitative data that MMF was seeing. In order to release this data back out to everybody, we built kind of two different delivery methods. The first is on the right-hand side. This is a snapshot of an 140-page long report that MMF collated with lots of graphics and lots of text in order to kind of explain some of their interpretations of the data. And then on the left-hand side here, this is a view into, not real data, but this is a view into a web-based visualization that we built that consumed secret shares and then created kind of an easy way to look through the data. And so this is a way to facilitate, a director of a museum who, again, is likely an artist themselves or a museum director. They wanted to understand how they were doing. They couldn't just like download CSVs and play with it. Instead, we wanted to give them a visualization that actually meant something. Great. And finally, in order to kind of socialize these results and get feedback, MMF ran a number of what were called convenings, where they brought together lots of different stakeholders. They talked about their findings. They talked about process. And for what it's worth, people were really impressed by the results. And they were really taken with the kind of ability that quantifying some of these experiences would have on their ability to make arguments for institutional change going forward. This went really incredibly well, and we were kind of at the end of this process, we decided, okay, we're going to run another iteration of this process this coming fall. Great. So the story of this NPC that I just told you is what I like to call the Instagram version of the story, in that it's been cleaned up a little bit, and it's presented in a way that you might want to see it if you're going to write like a conference paper, right? I tell you all the cryptographic details. Look, we did this high impact thing. It was so great and wonderful. But the truth, and this is true, I guess, of all Instagram pictures, is that once you zoom back a little bit, you kind of start to see some of the chaos and nonsense that happened behind the scenes that actually let this beautiful thing get created. So what I'd like to do with the rest of my time today is I want to go through and tell you kind of not only the good part of the story, but also the bad and the ugly parts of the story as well. Things that didn't work at all, and things that worked but maybe shouldn't have worked. In the hopes that there's actually a lot of socio-technical lessons that we can learn from this experience, such that as we're doing more deployments of cryptography in the future, we don't have to make the same mistakes over and over. Great. So as I go for this next telling of the story, I'm going to use the same kind of narrative structure. And certainly as I sat down to start this project, I thought this is what it was going to be like, right? I was going to start by having some conversations with them and then actually build a system, and then we were going to get the data, et cetera, et cetera, et cetera. I thought it was going to be very, very clear. And perhaps like the first most important lesson to learn about this is that it doesn't really look like this. It actually looks a little bit more like this. Right? Every time you're going to do a collaboration, especially with an interdisciplinary collaboration, you're going to make mistakes. There's going to be miscommunications. And oftentimes what that means is you're going to have to take, in order to take 2 steps forward, you have to take 1 step back. Right? You have to go and unsettle agreements that you had previously, re-examine things that you thought were done, and obviously, like, things take a lot longer than you want. So that's going to be the first lesson that I have for today. I think I get up to lesson number 20 here. So this is going to be our general structure. I'm going to kind of tell you a story, try to learn a lesson from it at the end, hopefully kind of cull down that 20 lessons into something that's a little bit more easy to understand and easy to process. Good. So the start of this collaboration, what actually ended up happening is the director of MMF, Mia, sent me an email out of the blue and said, hey, I heard about this thing called NPC. I don't really know what it is, but I hear that you folks are doing this for folks, and can we talk? And so what actually ended up, the reason she was able to find out about this is because of public and visible work on NPC, in particular the Boston Women's Workforce Council work. I mean, more particularly, she had a conversation with a social scientist who had heard about our work. And that social scientist told to me, okay, you should go and talk to Gabe and Maya because they're interested in this and they can help you out. And kind of part of the reason that this was front of mind for the social scientist is a couple of months previous to that, I had actually reached out to that same social scientist because I just wanted to chat. I thought what she did was really, really cool. And I wanted to kind of socialize in non-computer science. I wanted to hear what she was thinking about, share what I was thinking about, and be able to potentially look for modes of collaboration going forward. So this is another important lesson, at least for me, is that if you want to do work with people who are not computer scientists, oftentimes that means you have to spend time with people who are not computer scientists. And you have to do that work and you have to do that relationship building up front in order to find people who are really listening for good applications of our technology going forward. So once we kind of put the scope of the project together, what we did is we wanted to do some amount of demystification of what this magic of MPC was. Because it's really easy to describe it in ways that seem completely magical. And we wanted to make sure that MMF was very comfortable with, for instance, the threat modeling assumptions that we were making on our MPC. Right? That seems like a reasonable thing that we should check with them. And so we brought a bunch of their kind of senior like advisory board people into a meeting, and we introduced ourselves and we talked through, what is applied cryptography? What is cryptography as a whole? And then we went into a little bit more of MPC. We did some kind of in-person demos stealing from some of the work that I got from Emily Shen, which are kind of like classroom activities to do in order to get an intuition for what exactly MPC is. So this is like a voting protocol, which is very, very simple. We talked a little bit about linear secret sharing, but ultimately, remember, these people are artists. And so as soon as I told them that we were going to split the number 9 into 73, -15, and -49, they were like, why are there negative numbers? Right? This was not part of their kind of construct of how the world works. And negative numbers actually was a pretty significant lift for them. After we did this, they were feeling pretty comfortable with what we were doing, just to some extent, whatever extent they actually understood. They actually then did a bunch of convenings where they brought members of the art museum world together on a Zoom call. And they said, hey, you can ask us anything about the survey that we're going to run, or we brought these 2 cryptographers. You can come and ask them any questions that you might have about the security of the system itself. And so I think we ran about 3 of these. Each one had about 50 people on it. And so for a total of about 3 hours, and there were exactly 0 questions about the MPC. In fact, nobody was concerned in the slightest about the security of it whatsoever, which at least for me was a little bit of a bummer, but was also a little bit challenging. So one of the big lessons that I take away from this is that kind of the best practice when it comes to building trust is often to kind of do the like there's nothing up my sleeve approach, right? This magic that I'm doing, it's just math. I'm trying to normalize it. At the same time, a lot of these folks are not interested in the magic of the math, and they just want to defer to you. You want to say, okay, you're a security expert? Perfect. I will trust you in order to do this privately. And these 2 things are really in tension with each other. And I don't really know how to resolve this tension quite yet. What feels satisfying for me in order to make sure that people are actually bought into my models versus this is actually the socio-technical process. People defer to each other all the time, and this is actually normal. So there's something there that I don't quite know how to resolve yet. Great. So when it comes to system construction, right, we were sitting down, we're going to write all this code. This started about fall 2021. We had some initial conversations with them and trying to understand what they wanted, what they needed. So, okay, we have this code base that we're going to work from. And I said, okay, we've got plenty of time until we run this in fall 2022. We've got a full year. The one thing I'm going to need from you is I'm going to need a description of the computation that you want to do. In particular, I wanted like a circuit spec. Right? Once I had a circuit spec, I could implement it and all that kind of thing. I didn't use the word circuit spec because that wasn't going to work. But I said, okay, what kind of computations do you want to do? And they said, okay, makes total sense. We'll get together and do some thinking about what we want to do and come back to you. I said, great. So spring 2022 runs around. We hire a bunch of undergrads to start building out and kind of taking the Boston Women's Workforce Council system and building it into exactly what we want. Needless to say, hiring undergraduates to do secure engineering is not best practice. And they were not as productive as we might have hoped. Thus, I was the engineering effort in order to make this actually happen. But we get towards the end of the semester, the students are finally kind of understanding this code base, what's going on. They're ready to implement a circuit. And so we go back to MMF and say, oh, it's actually time if you could send us those. What kind of computation you want to do, we're ready to implement those. And they said, oh yeah, we've been working on this a ton. Things have been going really, really well. We have a good first version of our survey instrument, and we think it's actually looking pretty good. And for those of you who don't speak social scientists, a survey instrument is equivalent to MPC inputs. It has nothing to do with the circuit spec whatsoever. It has to do with the survey itself, right? What people see and what buttons they click. And I said, oh, actually, yeah, I must have said something wrong. Actually, I don't really care so much about that. Right? You could change the wording of the question at the last minute. It will not affect my life whatsoever. I need to know what kind of computation you want to do. Do you want averages? Do you want medians? Do you want quartiles? What are we talking about here? And they said, oh, okay, I don't think we understood it. We'll go into it. Okay. So summer rolls around, we get another intern, this one at a master's level, so things are a little bit better, to start integrating some the front end into the system. And things are looking pretty good. I can start testing it on my own. Things are great. We get to the end of that summer. And again, we're nearing this time that we're actually going to do the rollout. And I reach back out to the folks at MMF and I say, hey, it's really time now. We actually need to start implementing these so we can test them before a fall rollout. And they say, oh yeah, for sure. Some good news on our front. We've actually gone and vetted our survey instrument out with lots of different stakeholders. Everybody's really excited. We got some new questions coming in. And so we're feeling really good. I said, okay, I don't actually care about the questions. I need you to tell me what computation you want to do. They said, oh, wait, I thought this was one, and it was very clear suddenly that there was some kind of misunderstanding going on. And after a while, after reflecting on it a little bit more, I think a big takeaway for me is that I was not doing a good job explaining what the hard parts of computer science are, the hard parts of my job as the implementer. problems. And this reminds me of this, this XKCD comic, right? That nobody really knows what's a hard problem and what's an easy problem in computer science. And folks who are not computationally minded, it's not particularly easy for them to disambiguate this inputs to the function versus the function itself. This is a really subtle distinction, which I was unable to successfully communicate to them. And similarly, I think I was kind of one minus the problem in the other direction, right? When I was looking at what they were doing, I said, I don't care what the questions of the survey is. Make it whatever you want. It doesn't matter to me. I just want to know what the computation was. But truth be told, from their perspective, that was the hard part of the problem. That was the part that required a lot of effort and care and whatever. And so we were really seeing past each other. So there's kind of two major lessons that I think are kind of really enmeshed with each other. The first is that this distinction between a circuit and input is like highly non-obvious for people who are not used to thinking computationally. And the second one is that there's oftentimes this mismatch between the parts of the problem that are hard between different fields. And if you don't actually sit down and understand what exactly they're hoping to do, what are the things that they expect to take a lot of time, you'll run into these really weird, like not well parallelized time schedules, and you run into problems. So all in all, we got to fall 2022. We had no circuit specs. We were about to go live with the survey, and I had nothing I could test. But okay, well, you know what? This is the best we can do. What we're going to do is we're going to deploy the survey. We're going to gather the data, and then we're going to take kind of our time after the fact, and within a relationship between BU and MMF, we're going to define these circuits after the fact. And we looked really carefully back through everything we had said publicly. At no point did we kind of do any public disclosure about what type of computation we were going to do. This was very lucky. If at any point in time we had said anything about that, I would have felt very uncomfortable, but it ended up being something that we ultimately felt was not ideal, but okay. Good. So what did data collection actually look like? So in order to allow people to fill out the survey, they needed a place to go where they could actually fill it out. And the way that our system is set up to do this is we generate a unique link for each respondent of the survey. So that's an example of one up there with some different randomness there. So there's a survey ID, and there was also a participation code that was unique for every user. And then these will get distributed out to the 10,000 or so people who are given access to the survey. And this is actually a little bit messier than you might think. We as BU did not want these people's email addresses. I had no interest in any kind of information whatsoever about what was going on. And so we couldn't distribute these links directly to people. So the way the system is set up is that what we call the analyst or MMF would kind of log in, generate all of these links and send them out. But then we would see these randomized codes coming in. So neither of us would actually know who had filled out the survey. This was our kind of big idea in order to keep data as minimal as possible. Turns out mail merges are a little bit harder than you'd expect. And our friends are artists. They don't do mail merges all the time. And so there's a weird kind of distribution of effort across institutions. So some institutions wanted to distribute links directly to their respondents. So, the head of the HR office at, MoMA or whatever was going to be the one actually sending this out. And some of them were distributed directly by the Museums Moving Forward folks. So this is actually a non-trivial amount of logistics effort. But finally, everybody gets a link. People are filling it out. Things are looking great. I kind of see some results coming in. That's how we know things are looking live. Everything's great. Eventually, we close down the survey, and I go to start doing a little bit of this initial data analysis. And I notice there's a strange discrepancy in that it says that there are 1907, or maybe 1904, it's 1904, people who have completed the survey. But actually, when I look closely, I don't have 1907 sets of secret shares. I have 1920 sets of secret shares. So I have about 15 secret shares that I have no idea where they're from. I can't trace who made them there because I don't know who anybody is. Remember, there's this kind of separation between the random IDs that I see and the random ID and the identities that they sent out. So I have no way of tracking down where these secret shares come from or what happened. Eventually, we went back into the system. We started poking around in a much more detailed way because I'm actually deeply concerned if secret shares are just appearing. Like, that's a very bad sign. And it turns out when you hit submit answers, the page kind of spun its wheel for a moment. And the reason it spun its wheel is because I put, a normal KDF in there. It had a whole bunch of rounds of this KDF that were just iterating on top of each other over and over and over again. And if you were running it on a crappy low-end phone, that could actually take 20 seconds, it turns out. And I had a pop-up that said, don't close until this pop-up goes away, but people don't listen, right? So a big lesson here is that you'll never know how people are going to misuse your stuff. I had never once occurred to me that somebody would hit submit and then immediately close out a window before they even saw my pop-up that said, hey, you need to make sure that everything is done processing. But people do this all the time. And so we ended up just like losing somebody's responses. And I still, to this day, have no idea who those responses were from. Good. So I said I was going to tell you a little bit about one of the other surveys. So this was a different data input method that we gave to the HR representatives who participated in the survey. There's a bunch of data they had to pull out of their software, so it didn't make sense for them to have a web browser open the whole time. So we gave them an Excel spreadsheet. They would fill out all this data on the Excel spreadsheet and upload it, and then it would get automatically parsed in the browser, turn it to secret shares, and upload. This was our way of doing it and making their lives easier. And I spent God knows how many hours on this Excel spreadsheet, because I knew that if a bunch of HR people are going to put data in here, they're going to get some of the data formatted. It's going to happen, and it's going to be a pain in the butt. And so here's an example. This is if your employee workforce is unionized, in what year was the union first established? And it said this year must be between 1850 and 2022. So this was our way of saying, you really cannot upload this thing unless you, get a real number value in here. Not just like I put in 75 from 1975. We're not dealing with that kind of nonsense. And moreover, there's a pre-flight test, a tab that had all this kind of green and red. And if there was any red, it should get bounced from the system. You really want to make sure they're all green, and then you can submit it. So I was feeling really great about this. I had finally fixed my data input problem. Things were going to look great on this one. And turns out, when we're starting to analyze the data, it turns out that the average year in which a union was formed was somewhere in the middle of the year 20,756 or something. That was the average year. Because it turns out that somebody had managed to break my input validation. To this day, I have no idea how. I have actively tried to break my input validation, and I cannot do it. But somebody at one of these HR departments should probably get a degree in cybersecurity, because they are much better at it than I am. So one of the lessons that I learned from this is no, really, you really will never know how people will misuse your stuff. It's really, really, really hard to test these kind of cases. Good. While we're on a parade of things that Gabe did wrong, similarly, we're going in and analyzing all of the data and trying to build out these MPC circuits. And in all of my tests that I had done, it turns out the vector of secret shares that I was processing with had a particular length, something like 475 elements long. And so I've been testing everything like that. And as I got in to try to do this actual thing, I noticed that there weren't 475 elements to this vector. There are 474 elements to this vector. So what had I done wrong this time? And so I went back through and I was very careful in trying to figure out what I had possibly done wrong. Turns out, I had coded up a very important question, which was, what is your income? Which is something they really deeply cared about, how much more money we're making in the field. And I decided, okay, I'm going to make sure I have a regex here to make sure nobody could possibly put in like a number that isn't something reasonable. I had min values and max values, things were great and good to go. But I actually decided to turn it into text. And turns out our entire system, when it tried to secret share a string, silently failed. It just dropped the number and moved on with its life. And so every single data point with somebody's salary was silently dropped from the system, and there was nothing we could do to get it back, right? 2,000 people had basically already filled out this survey, and I had just trashed one of the data points that they are most concerned about. And there was nothing we could do. So one of the big kind of takeaways for me is one of the reasons that we failed was that we deferred the creation of these circuits until after we had done data gathering. I would have noticed this, actually, if we had had the test circuits and I'd run full end-to-end tests of the system, but I simply didn't notice this. And I filled out the survey. Look, there's 474 elements. Looks fine to me. I didn't bother to check that there should be 470. Good. So the computation itself is largely, I didn't lie to you too much about how the computation went, except that I did. So the first kind of thing that is a little strange about this computation is that it was in what I like to call the very much WAN model. Not the academic WAN model, no, not between data centers in different places. Remember, one is a server running in AWS East, and the other computational party is at a consumer-grade connection, which is a Wi-Fi connection to like a normal apartment building in the city of Chicago. Turns out, the city of Chicago does not have good internet. And regularly, their connection would just silently drop for a couple of seconds. And we designed a system that worked fine in our testing, but we had never tested it against a Wi-Fi connection in the city of Chicago, and it was not actually designed to recover from these intermittent stops. And so actually what happened is the entire computation would just crash and could not be kind of rerun at all. And so over and over and over, we tried to do the computation. If at any point in time we had any kind of failure, we would just fail the entire computation, which shouldn't be a huge deal if you have a 30-second long MPC, right? That shouldn't be a problem. Unfortunately, the computation we were doing was highly nonlinear. We were doing a bunch of comparisons and stuff like that that required a bunch of bit decompositions to happen. And remember, we did no smart preprocessing for the circuit at all. We just took additive secret shares at every single value that we got. And that meant that we had to, inline in our MPC, start doing bit decompositions right there. We couldn't do any preprocessing. And so our actual computation, when you kind of looked at it end to end, was between 15 and 30 hours long. It's a really long computation window, which is only compounded by the fact that the Wi-Fi in Chicago keeps crapping out on us. And so the entire thing would fall down. So in all, a lot of our computations took about a week to do, from start to finish, between us running it, going to sleep, waking up, seeing it crash, restarting it, getting on a phone call to figure out if they restarted it correctly, the whole thing. The upside of this, slow crypto works in some scenarios, right? Next time you look at your thing and say, well, it's not very fast, you have to remember somebody's going to use it in a time when it's totally not important for it to be that fast. They're just going to be really angry at you. Another kind of big lessons here is you should never defer on choosing circuits. This was a huge mistake. Just like never do this in case there's somebody there who's ever going to implement FPC. And also just kind of an interesting point, this idealized academic notion of what a wide area network is like deeply, deeply, deeply idealized, particularly in the cryptographic, right? Maybe if you go to a systems literature, they'll actually try to run things on phones or whatever, but come on. When you see WAN, you're talking about, US East to US West on AWS. Great. So the data analysis plan, right? Things are finally in a place where things should be relatively straightforward. So the way that this I anticipated it working is that we do a computation. Here's an MPC compute. We then give the outputs of this MPC to them. We didn't want to see any of these outputs. And then they analyze them. Right? So they got a CSV and they imported it, could do whatever they wanted with it. So that went well initially, until after about 2 weeks after they got the data, they came back to me and said, hey, there's actually some other queries that we wanted to run. Especially we looked at the data and we think there's some other questions that are really important for us to run in order to get the most out of the data. At this point, this is an adaptive query to a private data set, right? What's the security guarantees at this point? I have no idea, right? We're in totally a different world from any kind of analysis that we were used to doing in the MPC world, right? But at the same time, they were quite sure that if we didn't do these adaptive queries, that the whole experiment would really not be valuable from their perspective. I mean, ultimately, we were trying to kind of see if this would work, right? So it was really important for them to get this done. And so what ended up happening is we would get together and we'd have a discussion. We'd sit down and say, okay, what are the queries you want? And we talk about, okay, do you really need this query? Do you really need that query? Why is this one important? Actually, this one, I'm just not comfortable with at all. We don't have the enough data points to possibly run this one we can run. And we'd have these long drawn out conversations that were careful and again, within a kind of somewhat trusting relationship after multiple months of this of ongoing project. And eventually we'd decide on some subset of new queries and then we implement those and we'd run those. And the whole cycle would start over again. Right, so we ended up going through this cycle about 3 or 4 times in total. And for me, one of the kind of biggest lessons from this is that MPC didn't help me have these conversations. MPC actually made my life really difficult when it came to this conversation because MPC gives you no language to discuss the extent to which any given computation is or is not disclosive. This is not a problem with the definition, right? Our definitions are beautiful because it says the only thing that you're going to disclose is with respect to the function f. But then somebody says, can I run the function f? I have no idea. Why? And they say, you're a privacy expert. You should know. I said, oh, I'm not this kind of privacy expert. Right? And this was a really difficult thing that I wish I had had some support in having that conversation. One kind of upside from using MPC is that the structure of MPC itself kind of mandated that neither of us could unilaterally act. Right? We needed their secret key material and our access to the system together to kick off the computation. And that meant that neither of us could just run a computation on our own. So there's actually kind of this interesting structural thing that MPC did in order to create an environment in which we had to discuss these things carefully, which was really cool. The organizational reports, kind of the way that they would work, remember, people would go back into the system, they type in that password that they had entered before, they hit enter, and then download the secret share, decrypt, reconstruct, and build up this beautiful visualization. I tested my tool a bunch. It worked absolutely wonderfully. Turns out something went wrong. In retrospect, it should have been incredibly obvious what the thing went wrong was. Let anybody look at it and see if they had any guesses about what went wrong? Any guesses? Yeah? People lost their password. Yes, they did. And a lot of people lost their passwords. In particular, the directors of museums lost their passwords. And these are the people who are most important that they were able to see it. At this point, I can write more code to let you reset your password, but there was no code in there originally to do that. So we decided, okay, you know what? We have to generate this organizational report. And so we went in and we built an entire new code pathway to reset people's passwords, which as secure development goes, building new code pathways that touch, sensitive data, not a good idea. And we let people do this. So a major takeaway for me from this is that I think non-cryptographic account management practices, the kind of things that everybody's grandmother is used to using, is actually making our cryptographic account management much, much harder. I think in a world where maybe these people were trained to not lose their passwords a little bit more, they might have not lost their password. But truth be told, you can lose your password all the time. You just reset it by email, right? It's not a big deal. And so the kind of sanctity of this password, the importance of this password was really not undermined anywhere. We happened to be in a good place where we could kind of, catch ourselves back up. But there's somehow like this disconnect between what people learn in their everyday life and they move to a secure system and they have to relearn entirely new behavior. That's going to be a real barrier to deployment, I think, in the years to come. Good. The system's broken. It's actually not secure at all. I didn't put the slide on RWC. It was a little too shameful, but I'm embracing the CFAIL atmosphere. The organizational reports, right? So the way that this worked, right, is people would go in, they'd enter their password, hit submit. Remember, they create these secret shares, now it gets stored in the back of the system. One of them would get encrypted to MMF, and in addition to this, the encryption of this shared secret that we use as a password. And then to view the organizational reports, right, somebody would come back in, they'd enter their password, and then they'd download an encryption of the output of the MPC, this org report underscore MMF. This is one of those shares, encrypted under this KDF password. In addition to a share coming directly from BU, they'd reconstruct these in the browser. Yeah, one thing I didn't really remember is that MMF actually had everybody's links. They could go and try to log in to any of these kind of views, and they didn't have people's passwords, but it turns out it didn't matter that they didn't have people's passwords. In particular, I sent the secret share from Boston University in clear text. I did not require them to enter a password in order to decrypt that share, right? And so that meant that on the client side, they would get an encryption of one of the shares encrypted under a key that was known to MMF and a clear text share, which meant that MMF could actually have gone in and viewed every single one of these organizational reports, right? Thankfully, they're artists. And they were not going to be able to go in and actually change any of the JavaScript in order to figure out how to get it, right? Actually, what they do is they type in a password, they hit enter, and it would just error out, right? So in that sense, if I have a UI-bound adversary, right, if that's the world I'm living in, this was totally secure, not a problem whatsoever. But for any reasonable notion of semi-honest security, right, I just totally fumbled. I got it wrong. In part because I thought, okay, it's a share that's being held by BU. Why would I encrypt it under a key? This is a crazy thing to do. And partly it's because this was a new kind of system requirement. We wanted to feed different outputs to different parties who don't really have long-term identity, right? There was something weird going on here, but I didn't take the time to slow down and design the system carefully. I kind of looked for a quick kludge and did it. So what's the takeaway here? Don't roll your own crypto. Even if you're a cryptographer, probably don't roll your own crypto, right? In fact, what you should probably do is find another cryptographer to look at it and be like, you're a dum-dum, slow down, you did something wrong. And granted, they were me and my uncle both in this project, but we were both in a rush and we didn't go through any kind of vetting process besides, hey, does this look good? Yeah, it looks good, great. That was the whole thing. Good. When it comes to data release, MMF did a tremendous amount of work putting together this beautiful 140-page report. And things were going great. They sent us a version of it about a week or two before the release and said, hey, you just look over this. In particular, there's some language around what the MPC was. Can you look at that, make sure you feel comfortable with it? We said, great. We're scrolling and scrolling and scrolling. It's 140 pages. We got finally all the way down to the appendix, and we noticed that there's just data tables. Just page after page after page after page after page of data tables. You already have all these beautiful graphs. What are these data tables doing? And they said, oh, well, we're going to release all the data that we got to everybody. And we said, wait a minute. We looked at all these data tables and said, well, we're actually a little concerned that with all these data tables, you could give this to a first-year PhD student, and you're going to run up against the data reconstruction. They could eventually try to find a way to actually extract real data out of this, We weren't so concerned about this because, again, they're artists. They're not going to run a reconstruction attack. But if you release this data set, I mean, I'm going to send a PhD student to try and do the data reconstruction just because it's interesting, right? You can't just do this. And it was kind of at the last minute. And so we said, okay, listen, we usually don't try to be interventionist about these things, but you got to stop. Like, we're not releasing this data. We're going to go back in and do differential privacy for this data. And so we did a post-processing where we actually applied differentially private noise, all those kind of in the DP central model, and released those tables instead. One of the things that was interesting is that they were just following a totally normal kind of pathway for data release within their field. They were not doing something non-standard. So there's a lesson here, which is like the norms around privacy and trust are very field specific. In particular, the reason they were releasing all these data tables from their mind was to build trust with external analysts. They wanted people to say, you can do exactly the same analysis that we did and come to the same results. That was an important part of their process. But for us, that was a huge problem. Additionally, these norms are often implicit, and they only surface at the last moment, right? So trying to get ahead of them before they show up is really, really important. Great. The feedback sessions, for what it's worth, were exactly what I told you. They brought a bunch of people together. People were really thrilled and happy with the way everything worked, and they thought the data was really empowering to their cause. And so for me, I think there's a big lesson we learned here with, even though I just spent the last 25 minutes telling you all the ways in which I messed up in the system, they were still really happy with the results. We were still able to do something cool and powerful together. And I think that's because we tried to approach the collaborative relationship with honesty and trust, and admitting when we were wrong and trying to find ways to do better and try to invest in each other as people. So there's an opportunity to kind of recover from those mistakes and move through that tension. Good, so here's some kind of important lessons I want you to take away. There's too many. I'm gonna do a little epilogue after this, but kind of the big takeaways from the technical system that I want you to kind of think about is oftentimes there's this mismatch between what the hard problems are in two different fields, and not addressing that early can lead you to problems. Don't worry, we'll get to lesson 19 in a couple of slides. Lesson 11, MPC does not give us a language that we need to discuss the extent to which a function is disclosive. And this is just gonna be a huge barrier to getting MPC out there in any meaningful way going forward. We really need new tools, or just importing other people's tools in order to try to figure this out. The non-cryptographic account management part, I think, is actually pretty interesting. There's some kind of like, we're undermining our own progress in the security and privacy world by allowing some of these practices to be kind of hard-coded into people's minds that my password can only be recovered until it can't, right? And there's some tension there that I think we need to make. So good, and this kind of was all the stuff at RWC. There's a couple of more things that have happened since then in the last couple of months that I wanted to reflect on as well. So I'll call this the epilogue. The first part of the epilogue is I gave some version of this talk at RWC, which was lovely and a great experience. It was really fun. And afterwards, I was going around and talking to people, and people were really interested and they wanted to talk to me. It was great. And I got one of two, from any given person who talked to me, I got one of kind of two categories of feedback. The first category was almost exclusively from current PhD students, or maybe first year, maybe second year faculty, but kind of on the younger end of the community, who would come to me and say, this is so cool. How did you think to do this, right? What was the training that you used in order to kind of work through this? Like, how do you find people like this, right? They were interested, they wanted to figure out how it worked. They were really excited. The second was from more senior folks in our field, who always said basically the same thing. They would come to me and say, wow, that was a really good talk. I really enjoyed it. Couldn't we have just used trusted execution environments? And that was it. I said, well, yeah, we could use trusted execution environments. What we also could have done is we could have just used sending honest everything, right? Or just trust me, I'll stand up a server, trust me that I won't even look at it, right? That would also be a valid solution to the same problem. And it's not an incorrect kind of critique of the system. We could have used trusted execution environments, and I think there are some socio-technical things that come from using MPC, but I think there's actually a bigger lesson to be learned here about a different kind of vein of seeing a problem that's starting to exist in our field. And so a big lesson for me is that as our crypto gets moved out into the world, we're seeing actually fractures within our own community about how people appraise the work that other people are doing. One is, does it have impact? Did it help? Did it do something interesting? Did you encounter problems that were novel to our field? The other one is it cryptographically interesting? And those two things have a hard time living in tension sometimes. In particular, for me, complexity and impact comes from engaging with these systems, not only technically, but also socio-technically. And we need to find ways to value that and kind of celebrate that, particularly as younger members of our field are getting excited about doing this kind of work that really might have a hard time getting accepted to crypto, for instance. At the log part 2, about a month ago, maybe 3 weeks ago, we got an email from the folks at MMF, and they said, hey, we had talked about running another iteration of this in the fall, but you haven't heard from us for a couple of months. We've been doing a lot of thinking, and we've decided that we're going to move away from the MPC-based system and instead move into just a normal survey platform. And in particular, they said, the privacy, we think, helped, but ultimately, we don't think that people were as concerned about privacy as we had initially been concerned about. We didn't really hear any feedback from people saying that the privacy protections was important, and it was kind of a nightmare. Remember those week-long computations we had to do? Like, that was really a pain in the ass, and we don't want to do that. Like, that's my opinion. They're much nicer. Right? We don't really want to do that. We said, we totally understand, right? You should do what's important for your organization. And me and the cryptographer had a kind of long conversation about whether or not we bought into this idea that they hadn't received any feedback about the privacy protection as being a validation that they didn't need it, right? We're not convinced, right? That's a complicated idea because you don't know how many people wouldn't have filled out the survey if the MPC wasn't there. You just have no way to check that. Right? Or how many people would have felt compelled to share the data, but would have felt much more comfortable with it? We simply don't. So this is a big open-ended question. For me, there's a big kind of important lesson here is that it's really easy to kind of kick usability down the road as an implementation detail. But if your stuff is not implementable, it is not sustainable. People will not come back and use it again if it requires them to wake up in the middle of the night to keep over their laptop. Not going to happen. Right? So maybe we should be thinking about the structures within which we build our cryptographic systems to see, do they lend themselves to usability in any meaningful way? And if not, that's going to be some trouble. So what's next for us? We are now in the very beginnings of a process where we're building out a system that doesn't require me to be an engineer, which I'm incredibly excited about. The vision here, I'll just tell you this quickly. What if you had a system that the front end was like Google Forms, where you could build a survey on your own? And the back end was just MPC. Everything looked totally normal from a usability perspective, but actually there was MPC happening on the back end. This is not a crazy idea. This is related to a lot of the ongoing standards efforts and whatever, but I think there's a lot of interesting questions to be solved on transparency and communication in addition to systems building that we're going to hope to be tackling in the next year or so. So just a closing thought and then I'll be done. I attribute this quote to my colleague Maya, who then further attributes it to Ron. So it's not exactly clear who said it, so I'm just attributing it to both of them. But they like to say that cryptography is a social science masquerading as right? And that what do we spend all of our time doing is we look at relationships between different people, and then we try to codify it. Like we try to literally codify it. We make them into code, right? We make them enforceable with mathematics. But that means that we have to spend a lot of time and effort understanding what are the relationships that exist between people in the first place in order to know what to build. So in my mind, I think that this is kind of a little bit of a call to action about part of studying cryptography is also studying how trust operates outside of the cryptographic building blocks. And that's going to help us shape what we build in the future. And I'll just say this as a very kind of quick provocation. I don't fully know what it means yet. I'm still thinking about it a lot myself. We think a lot about the ways that we can take existing relationships and turn them into code or turn them into math. But we don't actually know so much about what happens when you introduce new privacy enhancing technologies into relationships. Actually, how does it change the relationships that people have? Right? In particular, I've started to think about MPC as being a really good kind of slow ramp up of trust. That is to say that at the beginning of this relationship, we did not know each other, and they didn't know any of their stakeholders. But we spent a year working together where we didn't have to trust each other, maybe technically to look at the data, but now we have a relationship on which we can fall back on. And that changes what we're able to do as a collaborative effort between us. And so something about our social relationship has changed as a result of using the technology itself. I mean, I think that's a particularly interesting thing to think about. So that's it for me. Thank you so much. Thanks to all my co-authors and the many, many students who helped actually build various parts of the system. If you're interested, that's a link to MMF's report. There's a bunch of cool stuff in there. Thanks.
Thank you very much. Do we have questions?
So you said you collected the data before the circuit was known. So what did the people who are filling the survey know? As in, you said that it's going to be private, but clearly that depends on what the output being. Like, why were they trusting in the first place?
Yeah, so again, we went back through all the statements we made to try and figure out if we committed to anything, even informally. There was basically no commitment to anything. The language we oftentimes were discussing is that nobody would see any individual level response, which is true. It's not very satisfying, but boy, is it true. I think this was a significant failure, and we actually don't totally know how to communicate with end users about MPC's guarantees. That's the project that we have ongoing right now to try to figure out, like, what do you do there? And it's something I think is actually genuinely very interesting. Yeah.
Do you think, like, once sort of passkeys and those types of automated authentication passwords, like replacement systems, become more standard, that will solve some of the password problem, or no?
Yeah, I'm open to it. I'm trying to hold back my future. I'm holding back my claims as much as possible, because I think that there's two different levels on which it's true. One is that people might be able to come to a platform like this already with cryptographic identity, right? That would be huge, actually. On the other hand, I don't know about how the existence of those types of identity are going to shift and change the social relationships people have with it, right? So those two things might be fighting against each other, and I just don't think we know yet, which I think will be really interesting to find out in the next 5-10 years.
Is it correct to say that there was a big, maybe even a complete overlap between the people who were building the system and the people who were testing the system?
Yeah, I mean, n equals 1 for both. So that's like a little bit overstated, maybe a little bit. Other people did look at parts of my code base. Kenan, who ran the crypto provider, the correlated randomness provider at Brown, he was the initial architect of the library we were using, and so he did go in and look at my code occasionally to look at stuff. I was still the one defining test cases as well as building out the system. In part because we just didn't have the labor available. That's not true. We had plenty of undergrads. We didn't have a high quality enough labor in order to actually test our system effectively. And our original goal had been we were going to get lots of PhD students at BU to go in and test the system. But the truth is we didn't have any circuits, so it wasn't clear how to test the system yet.
So there was then, like, small follow-up question, no idea of doing like a test run on the side of either Boston University or the Museum Foundation? Like nobody.
No, they were pretty. Yeah, that was kind of a non-starter. I think they were afraid that they had a relatively short or a small amount of trust that they could use, and they didn't want to kind of consume any of that trust relationship with their kind of participating museums to run a test run. They were afraid that people weren't going to fill out the survey at all, and so they kind of allocated their trust budget to the main thing. So there was really, I think we talked about it briefly, but it wasn't a realistic option.
Like, I mean, just like 5 people could have tested it who were on the side of the Museum Foundation, right? It didn't need to be like a full.
Oh, sure. We just didn't have circuits.
Okay, yeah. Okay.
It filled out the front end, but if you don't have circuits, it doesn't help there. Yeah. I mean, there's other failures I didn't actually talk about here, right? The whole system was built in a way with asynchronous callbacks, and we ran out of memory in the browser, and we had to do all kinds of other engineering things that we also ran into at scale, which we would have missed actually.
I have a question. Did they consider, or are they considering adding a question to the survey about the impact of privacy on the survey? So like, have they considered asking people if they liked the MPC or if they care about the privacy as one of the questions on the survey?
Good idea. We'll talk. See what they will.
Yeah, so I had a question about how do you help people kind of understand the capabilities of the functions? Like one of the huge issues with building your circuits is like they have no idea how whatever thing they're thinking of in their mind actually translates to a circuit. And so I'm wondering, like, is research towards that around like having like interfaces for people to like kind of build computations and then translate those to circuits, or like translating like Python, like data science library queries into into circuits?
There's definitely in the systems world some work going on, including mine. I think with a paper coming out sometime soon, doing exactly this, looking at Python building and whatever. We were in a circumstance where the 2 people on their side who were kind of defining the scope of the survey. One was a literal artist, and the other one had a background in statistics. She's a PhD in stats, and therefore had a pretty good idea of exactly what things she wanted to do. I don't think she's a Python programmer. She might have been, but instead, really, what we did is we discussed it in words, and then I ended up building out the circuits. There are kind of some automatic compilation tools if you have a slightly more sophisticated kind of analyst, and certainly with the system that we're building next, we're looking at kind of compiling those tool chains directly. Yeah.
Other questions? All right, let's thank our speaker again. Okay, so we're going to take 15 more minutes here on the puzzle competition before we present the answers, but I do want to give a hint on the LWE puzzle because that seems to be causing people the most trouble. Before I give the hint, are there any final answer submissions, or do we all need the hint? Okay, we all need the hint. All right. Okay, so for the LWE puzzle, you've probably gotten to the point where you realize that the individuals each correspond to a crypto accepted paper. It seems a lot of sticking point is to combine that list of accepted papers into a short clue. So I want you to think about the learning with error structure, where like each one of those things is basically an equation, but it's slightly wrong. So it might not be those papers you're combining. It might be papers near to them that have some kind of commonality and might represent that short clue. So hopefully that helps. We'll give you 15 more minutes, and then we're going to announce the results.